Welcome to a video on the p-series test for convergence of an infinite series. The p-series test states if we have an infinite series in the form of 1 over n to the power of p, if p is greater than 1, the series will converge, and if p is less than or equal to 1, then the series diverges. And we alluded to this connection in the integral test video where we looked at when p was equal to 1 versus p equal to 1.1. So the p-series is a shortcut to applying the integral test if we have an infinite series that fits this form. This test will be very helpful in the next video when we talk about the comparison test. So if we take a look at this infinite series, it does fit the form for the p-series. And since we can rewrite this as the summation from n equals 1 to infinity of 1 over n to the power of 1/2, the exponent on n, which we call p, is equal to 1/2, which is less than or equal to 1. Therefore, we know this infinite series will diverge. So we can state the infinite series diverges by the p-series test. So it's a nice quick way to determine if an infinite series diverges or converges if it fits the correct form. So for this example, we can rewrite this as the summation from n equals 4 to infinity of 1 over, this would be n to the, remember it's the exponent over the index, this would be 4/3 power. So our power is equal to 4/3, which is greater than 1, which is enough information to determine that this series will converge by the p-series test. Again, this is a shortcut to the integral test. If we let f of x equal 1 over x to the 4/3 power, we could apply the integral test to show that it converges as well. But this is obviously a much easier, shorter way to show that it converges. Let's go and take a look at one more. For this series, we can factor out the 4. Then we'd have n to the 1/2 in the numerator and n to the 4th in the denominator. And if we're going to use the p-series test, we cannot leave it in this form. We're going to go ahead and rewrite this as 4 times the summation of, remember if we're dividing here, we can subtract the exponents. So this would be n to the 1/2 minus 4. That would be n to the negative 3.5 power, or negative 7/2 power, which is the same as 1 over n to the positive 7/2 power. So we have p equals 7/2, which is greater than 1. So by the p-series test, this series converges, and multiplying it by 4 does not affect whether it will converge or diverge. So the original series converges by the p-series test. And that's going to do it for this video. Again, we'll make use of this p-series test again in the next video when we discuss the comparison test. Thank you for watching.